All right. So for the SATs, I just want to kind of go through them. Hey, come on. All right, we did, I think, up to 13 yesterday, correct? All right, so here we go. Number 14. Now listen, I need everybody to put a star by number 14. This is just a really good problem. All right, and it's something I need for you to understand. All right, so please take a look. All right, I'd probably say 14 is a good problem that's about as hard as it gets. All right, and I really want to talk to you about 14. I want to make sure that you understand what I'm telling you. All right, on all these SATs. All right, they always ask about slopes. And right now, for question number 14, it says the equation above shows how temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius. Basically, the equation which the following must be true. All right, I really want your attention up here, please. All right. Now, does everybody understand this is linear, correct? That is a linear function. All right. Now, I need someone to tell me, what does the 5/9 represent? What does it represent? It represents the slope. All right. So now what I really want you to concentrate on, and I really want you to listen to me on, is what does that 5/9 mean? Someone want to tell me, what does the 5/9 mean? In what? In temperature. Now there's a specific relationship, very specific. And this is what I want everybody to be able to tell me. All right? If the slope is 5/9, now I need you to look up here. If the slope is 5/9, I would like for you to understand that the 5 is the change in Celsius. So every 5 degrees change in Celsius, there would be a what? 9-degree change in what? In Fahrenheit. Make sure you make yourself a note on that. For every 5 degrees change in Celsius, there would be a 9-degree change in Fahrenheit. Unfortunately, that wasn't one of the choices. All right. Unfortunately, that was not one of the choices. All right. So what do I have here? I have this. I have a temperature increase of 1 degree Fahrenheit is equivalent to an increase of 5/9. So instead of looking at it as a fraction, 5/9, they want you to look at it as a fraction as what? 5/9/1. Think about what I just said. 5/9 can be written as 5/9/1. So what does that mean? That means for every 5/9 degree change in what? Celsius, there is a what? 1 degree change in what? That's why number 1 works. All right, that was very tricky. Very tricky. All right. What's the matter, Walker? No. The fraction 5/9 can be written as 5/9/1. Do you agree with that? That means the numerator is talking about the change in Celsius, and the denominator is talking about the change in Fahrenheit. So as the Celsius changes by 5/9, the Fahrenheit would change by what? That's exactly what that says. That's exactly what that says. Now keep concentrating. Now how do I know that 3 is not correct? Because it's the same, right? Essentially. Right? If 1 is changing by 5/9 and the other changes by 1, that same relationship can't apply to the other one. Do I agree with that? Right? So I knew right off the bat that it had to be either 1 or 3. It couldn't be both. So I know it's not 3. Now just by my basic understanding here, I know that if 1 is true and 3 is not true, I do have to check on number 2. Now please look at number 2, because this one is the what makes this problem so great. They were talking about fractions, right? And now they're talking about what? So I knew there had to be a little trick, right? So 1.8 is the same as what fraction? 9/5. All right. 1.8 is the same as 9/5. So I want everybody to write that down. 1/8 is the same as 9. 1.8, thank you. 1.8 is the same as 9/5. Everybody good with that? Now I knew that 5/9. Now this is why it's tricky. 5/9 is the same as 1/9/5. Think about that now, please. I'm not expecting you to know that. I'm just expecting you to say, wow, that's pretty cool. All right? That's very difficult. I would not ask the average kid to know that. Now, why is that important? Because now I could rewrite this as C is equal to 1/9/5 F minus 32. So now that means what? When there is a 1 degree change in what? Celsius, there is a what? 9/5 change in what? Fahrenheit. So that one is correct. All right. So the correct answer for that was D. Again, that was very sneaky. Very sneaky. Yes. The reciprocal. That's what we do. Essentially. Well, I think it's just a matter of how you're looking at the fraction 9/5. A lot of people had no idea 9/5 and 5/9. Right? Seeing it's just a reciprocal. All right, very tricky problem. Yes, very good. And that's why they disguised it by putting what? 1.8. All right. It would have been much easier, I feel like, if they would have written what? 9/5. I feel like people could have seen it better. All right, very tricky. All right, let's take a look quickly at 15. The graph below shows the total number of music album sales in millions each year from 1997 through 2009. All right. Which of the following best describes the general trend in music from 1997 to 2009? What is that, guys? I'm pretty good with that. Does everybody agree? I don't think that was too bad. All right. Let's look at number 16. The graph above shows Marilyn's distance from her campsite during the 3-hour hike. She stopped for 30 minutes during the hike to have lunch. Based on the graph, which of the following is close to the time she finished lunch? She probably finished lunch around what? About 1:40. Does anybody need any help with 16 being C? It's totally okay, as long as you're good with the answer now, with the explanation. All right, come on, guys. This is really important to pay attention. Listen, make yourself better. All right. Now for 17, I felt like this was kind of easy also. Right, it's a matter of just looking here, guys. If it's linear, the first thing I'm looking at is the slopes are all what? Slopes are all different. Do you agree? So all I need to do is figure out what the slope is, right? So 7 minus 4, 4 minus 3. So therefore my answer is, yep. And you can just plug them in. But again, I'm not arguing with you. Plugging them is perfectly fine. I'm just simply saying, based on observation, I knew the slopes were different. So if I knew if I could find the slope, I'd have the answer. Everybody agreeing? All right. Now let's move on. Let's check out 18. All right. The average number of students per classroom at Central High School is modeled by this linear equation. All right. Where X represents the number of years and Y represents the average number of students per classroom. Which of the following best describes point 56? Point 56 is the what? It is the slope. It is the slope. Anybody have any questions with that? Or right, if 0.56 is the slope, that represents the change of y over the change in x. And what is y describing? Right, the average number of students in the classroom. So that would be the change of y over the change of x. And what does x represent? Number of years. Right, so it would be per what? Per year. All right, so the correct answer would be what? The estimated increase in the average number of students per classroom each year. All right. And let's take a look at 19. Anybody get this? All right, so now this represents the what? The x value. So you put this in for x. -2, parentheses, -3x plus 5. That's what that means. You're replacing x with -3x. So my answer is what? 6x plus 5, which would be B. All right, here we go. Let's check out just a few more before we get started. All right. It says, so now this one's not bad. For the swim that took 34 minutes. So I'm trying to find 34 minutes, correct? So this to me looks like 34 minutes. That's the actual, and this is the what? Estimate. Does everybody agree with that? I didn't think that was that hard. So counting by twos, right? 142, 44, 46, 48. I think the answer is B. Right? And again, I'm hearing some things about, you see the problem again in the second and third time. You're supposed to be getting better at it. That's why the problems are broken down like this. All right, you're supposed to be getting better as you're going through the problems. You're not supposed to know them up front, but by the end, you're supposed to catch on. All right, that's what I'm expecting out of you guys. All right, now, I don't know, how many more do we have? 2. Okay, so that'll be good. All right. Oh yeah, I made a mistake on that, so I just did the same one. All right, so let's look at 22 now. All right, while preparing to run a marathon, Amelia created a training schedule in which the distance of her longest run every week increased by a constant amount. If Amelia's training schedule requires that her longest run in week 4 is a distance of 8, so what I did right off the bat was I put down week 4 was equal to what? 8 miles. And then it said her longest run in week 16 is equal to what? 26 miles. Does everybody agree with that? Now, I was hoping you would kind of figure out we're just trying to what? It says increase by the same amount. Right? So you're essentially just finding the slope. Right? So that means I'm going to increase a grand total of how many miles? 18 miles in 12 weeks. That's exactly correct. So I can reduce it down to 1.5, or I can say I'm going to do what? 3 miles every what? 3 miles every 2 weeks. Amelia increases the distance of her longest run by 1.5 miles each week. All right, thank you. All right, I don't think that was too bad. All right, now let's look at last one, 23. Line L contains points from each quadrants 2, 3, and 4, but no points from quadrant 1. Which of the following must be true? Come on, guys. What is this? I got a C and I got a D. All right. So now, again, regardless of what you thought, again, you're just understanding that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4.
I understand why.
Okay, Walker. So it says line L contains a point in each quadrant, 2, 3, and 4. So if I'm in 2, 3, and 4, but not in 1, you have to draw a line. So it has to look something like this. So it definitely is what? It has to be a negative slope. All right, it has to be a negative slope. Okay, now, remember, hey, listen, the more time you spend on this, the better it is, obvious. All right, and again, that is really, really good practice for all that you need to understand about lines and graphs. All right, now today we need to move forward on our geometry, which honestly, the beginning of the section I asked you to read yesterday a couple pages, and I'm sure everybody did that. All right, but basically, does anybody want to give me a summary, or should I just good? Thank you, McConnell.
It's on triangles. How you can use them to find missing variables and the angles and the types of triangles like scale and equilateral.
Yeah, so they were. Do you agree it's something you've seen already? All right, that's why I just went ahead and jumped through it. All right, we just finished it off. All right. Now, if I'm not mistaken, they talked about congruence too, correct? All right, for those guys who read it, talked about congruence. And how do you tell if something is? How do you tell if shapes are congruent? All of their what?
Sides and
All the. Listen to me now. All of the corresponding sides have to be congruent, and all of the corresponding what? Angles have to be congruent. Now, if the corresponding angles are congruent, does that make it congruent? No, because it could be blown up, right? Or it could be shrunken down. All right? Just because the angles are the same does not make the shape congruent. All right? Also, you can think about a square and a rectangle. They all have 90-degree sides, but they're not always congruent. Everybody with me? All right? So in order for something to be congruent, you have to show that all of the angles are congruent and all of the what? Sides are congruent. If you establish that fact, then you can say that the shapes are congruent. It doesn't matter if it's a triangle, a rectangle, it doesn't matter if it's a five-sided figure, it doesn't matter what type of figure it is. All right, does anybody have any questions? All right, so again, if you didn't get a chance to read that, I'm telling you, do yourself a favor. It just is not a difficult thing to do. Most of it you're going to say, that's obvious, but again, it'd be something that you should have done. All right, now I want to talk about today's lesson, so let's go back. In today's lesson, if you want, take out a sheet of paper. We're on section 4-2, and it is page 250, numbers 1 through 15, 17 through 32, 36 through 39. No, I'm not posting this on Google. All right, you're working on paper. You're working on paper. Now again, remember, I'd like to go ahead and get started as quick as I can because we spent a good amount of time, all right, looking over the SATs. All right, now this section again, I believe is very easy also. Very easy. Now, in general here, they're talking about this. Listen, in general, they're talking about the angles of the triangle. And I'm pretty sure if I said what's the sum of the interior angles of the triangle, you can say that they are 180 degrees. Now, obviously, we can prove that. All right, we are going to be able to prove that. All right, and again, so that's not going to be a postulate, that's going to be called a theorem. So the sum of the interior angles of the triangle always add up to 180. Go ahead. So now, let's go ahead and knock out these first 11 questions. Pretty easy. All right. We're on page 250, or you can just look up on the board. So again, number 1, angle 1 has to equal. What is it? I think you're right, 58. Now, for those of you guys, again, always working on the mental math here. Does everybody agree that if the angles were all equal, they would be 60 degrees? So what I'm trying to show you now is if this was 60, this one's 1 under, so this would have to be what? 61. And this is 3 over, so that would have to be 3 under. So that's how I got 58. So I'm okay with that. I know what you're saying. You can just add them up and subtract from 180. I don't even care about that either. All right, we're working on the mental math, trying to get some of you guys better at numbers mentally. I don't want you using a calculator every second. All right? In class, I prefer you not use a calculator. I don't care if you use it at home because I know you got a lot of work to do. All right, you want to make it easier on yourself? That's fine. Go ahead. I don't care. All right, now let's look at question number 2. All right? Again, what we need to do is we need to look at the symbols for parallel. All right? I'm looking for angle 1, angle 2, and angle 3. Somebody obviously tell me what angle 2 is. 39, right? Because it's alternate interior angles. Here we go. Those have to be equal. So that's 39 degrees. Also, these are parallel. If CD is perpendicular to FC, then CD must also be perpendicular with what? That's right. Thank you for listening. DE, perfect. So that has to be a right angle. Everybody agree with me? So now you should be able to quickly tell me what 3 is. 51 degrees. Good job. Now, the angles of a triangle always add up to 180, right? So if one angle is 90, that means the other 2 angles have to add up to what? Come on, everybody listen to me. I'm not asking you to do 180 plus 90 plus 48. That's silly. If one angle's 90, the other 2 must be what? 90. Get that in your head. All right? So angle 1 must have been what? So far, it's really simple. 42 degrees. All right, here we go. Number 3. All right, now, I want to show you something here real quick. All right, and again, please, everybody take a look at this. All right, here is a triangle. All right, and this will make sense to you. This is called an exterior angle. Everybody with me? These 2 angles over here are called the remote interior angles. All right? Is it this angle right here? Is that still an interior angle? Yes, but it's not a remote. It's not, or it's connected to the exterior angle. So I want someone to try to tell me something about the relationship between the exterior angle and the remote interior angles. What are you thinking?
I was going to say about the non-linear.
What are you thinking? Okay. So what are you thinking? Very, very smart. Very smart. Now listen, I'm going to try to demonstrate, and this is going to be a proof. But again, I don't really care so much about the proof. I would prefer, right, that you're looking at this going, wow, that makes pretty good sense. Now, how did she make sense out of that? Because the angles of a triangle all have to add up to what? 180. So listen to me now. And again, here's what I'm talking about. I'm trying to help you numerically understand what we're doing. So look up, please. Right? We don't have the numbers, but I would like for everybody to say, come on, I need you listening. Some of you guys are fumbling around doing homework, and I don't care. All right, you got to hear me. You got to be listening. This is about making your brain think better about numbers. So I want everybody to take a look at this. This angle right here. I'm sorry, Mike. This angle right here, this angle right here, and this angle right here have to add up to what? 180. Do we agree? Then these 2 angles have to add up to what? 180. Does everybody agree? So what I want to just quickly identify is, let's just say this is 1, this is 2, this is 3, and this is 4. Now again, you just have to, again, visual. All right, the hardest part is I'm naming them numbers. But come on, stop and watch. It's going to look kind of funny, but I'm going to say 1 plus 2 plus 3 is equal to how much? 180. And then I'm saying what? 3 plus 4 is equal to what? 180. Because, thank you very much, because they're both equal to 180, I can now say 1 plus 2 plus 3 equals what? 3 plus 4. Everybody good with that? So those things are equal. Now, what can I do with the 3's? Cancel them out. So 1 plus 2 is definitely what? 4. Now, obviously, 1 plus 2 isn't 4. Those of you guys who are laughing at me are not paying attention. Those numbers are referring to the what? The angles, that's all. So now we just did a quick check on what? The exterior angle is always equal to the what? Remote interior angles. Is that something necessary that you have to remember? No, but it's going to be on the SATs, and speed is important. Right? Now, how do I know that? Example right here for 32. If I don't know how to find angle 2, and I didn't remember that the remote interior angle is equal to the exterior angle, I could simply find the missing angle here, right? By going 180 minus that. Is everybody good? Hey, come on. And then I'd have to add these two angles and subtract from 180 to find that, correct? Or I could just say, well, angle 2 has to be 112 minus 32, which is what? All right? Is everybody okay with that? 80. Now look, again, I'm trying to help you. All right? Think about the geometry a little bit differently. Everybody okay with that being 80 degrees?
I understand I didn't put the right way, but I got it by pretending that line was supplementary, and so I still got it.
Yeah, and again, what he's bringing up a very good point. As you're doing these problems, that's why I try to tell you it's hard for me sometimes to evaluate your work because you're thinking a little bit different than me. That doesn't mean you're wrong. That just means I got to figure out what you're doing. Do I agree with that? All right. So there's lots of ways to solve these problems. I'm just trying to find the fastest, most efficient way to do the problem. All right. Does anybody have any questions with that? I don't think that's hard. All right. So here we go. Let's look at something else now. All right. What do we got next? Question number 4. All right. So this right here, obviously, is how much? What is it? 101 degrees. Everybody happy? Pretty good. Pretty easy. Remember, that's the exterior. Very good. That's what you got to find. The exterior, boom, boom. Add those together. All right. Now, if I'm not mistaken, I just hate when they do this. All right. I hate these figures over here. All right. So what I'm going to do here is, what we're going to do is, again, for me, and hopefully, you can see it this way. And now I'm kind of moving it around a little bit. All right, that's kind of what we're looking at. All right, and it says the measure of angle 3 is how much? 53. So now I'm going to go back and put 53 right here. And then angle 1 is what? 102. All right. Now, honestly, we could find the rest of the angles, correct? But I definitely can figure out 2 real quick. Angle 2 is just what? Come on, guys. And angle 2 is this guy right here. 4 is this, and 5 is here, and 6 is here. So thank you again. 2 is what? 78. Does everybody agree? 78. Now, if angle 2 is 78, then angle 5. Look over here. I just think it's easier. Let's look at angle 5. What would angle 5 be? 78 plus 53, right? Does everybody agree with that? Now remember, I don't care about a calculator. Now's the time you're practicing. 78 plus 53. Angle 5, 131. Thank you. Which now I think it's easier to do 4 then. 4 is what? 49. Or 59, which one? 49? 49. And now angle 6. What is that?
127.
127. Thank you. Look, guys, and I'm just telling you, you know, some of you guys, we're talking, and as I have conferences with your parents, these are the types of things you need to try to beat the person. It's like a little game. You're trying to be faster than they are. It's annoying every time someone says the answer. So you try to beat them to the answer. All right? That's what I'm hoping you do. All right? I don't want you just let someone else give you the answer and then you just write that down. Have you learned much? No, you haven't. Don't write the answer. Make sure you know what the answer is. And if you don't know, please ask. Number 5. Is number 5 59 or 49? Oh, I thought you were saying angle. I thought you were saying angle. Sorry. I was looking at that. So you're telling me question 5 is I did that wrong. Or, yeah, question 5 you think should be 59? Is that correct?
No.
No, it's 49. It's 9.
Now listen, I want to try to help some of you guys with that too, the mental math part of that. Listen to me. Because again, I'm glad you said that. All right, listen. Because when you're subtracting 180 minus, what are we doing? 180 minus, what was the other angle that we were referring to? Angle 5 was 131. Listen how you should be doing that. You should be doing 180 minus 130. Then that's what? 50. And then 50 minus 1. Does everybody understand what I'm saying, right? Don't be borrowing anymore. You're better than borrowing. You're just subtracting, right? Subtract the big number from the small number. That's what I hope you're understanding. The other way to do it is just to count up also. All right, but to me, the subtraction, where I always do the big number minus the small number, and then I know I'm just going one more less. All right, hopefully that makes sense. All right. Yes, just be careful. All right, now let's do 9, 10, 11. All right, so here we go. I know because that's a 9-degree angle. Somebody already ahead. What do we got? 61. So everybody agree with Walker on 61? All right. Now, angle 3. Thank you very much. Has to be 12 because I'm just going 29 minus 17. Right? Then angle 2, I can just do 180 minus 29. So I'm doing 180 minus 20. There we go. These 3 angles, the relationship, 3. Angle 3 plus 17 equals 29. 29 is the what? Exterior angle. Angle 3 and 17 degrees are the remote interior. All right? You're very welcome. All right, any questions? All right, what time is the bell ring today, guys? How much? 27? All right, I got 10 minutes. I think the rest of these I'm just going to flip down here. I'm trying to find maybe if there's a proof or something. Shh, 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 shh. Walker, you're supposed to, I sure hope there's like 5 of them. That's what Walker said. He was hoping there were 5 of them. Oh. All right, so did I ask you to do 34
No.
and 35?
It's 17 to 32 and
Darn. Yeah. All right. So again, guys, don't be the triangles is one of the most important things on the SATs. The triangles and the parallel line stuff. All right, very important on your SATs. So please do a good job of this tonight. I think I posted the solutions. Listen, I need you to look up the solutions. Make sure you're correct. If you don't know how to do something, it's there. Everybody good? All right, get to work.